Today, I'm going to share the best way to colorize old black and white footage from the last century. Here I've prepared a black and white video showing the panorama of the Grand Canal in Venice, filmed in 1896. I've also prepared a colorized reference image taken from one random frame of this black and white video. Today, there are many ways to turn a black and white image into color, but in this video, I'm using the website colorize.cc. The reason is that single image colorization tools often make colors too bright or change details in the image. You need a model trained to understand colorizing video. Colorize.cc meets that need and is probably the best model available. Because most old footage has noise, flicker, grain, and so on, the first step is to pre-process it. Here, I use StaxRip to remove these issues. To speed up the workflow, I've added an AviSynth script to StaxRip, which can fix basic issues in black and white video. This code stabilizes frames, cleans spots, preserves details, reduces flicker, and more. Next, just add the video we need to process and start the processing. The processing time depends on your computer's specs. If you have a strong CPU and GPU, it will be very fast. With my computer, it takes a few minutes, so I will fast forward this part. StaxRip has finished running. I'll show you the results and compare them to the original video. You can see the new video on the right has much less grain and flicker. I also added white balance in the script, so the video has better contrast. However, to keep the video realistic, I recommend not reducing noise and grain too much. The next step is to colorize the video based on the reference image. After trying many methods like deoldify, DD color, deep remaster, and deep exemplar-based video colorization, I found that ColorMNet is the most balanced at spreading colors across frames without errors. So, I decided to run a Google Colab session using ColorMNet. To run ColorMNet on Colab, you just need to run each code cell one by one from top to bottom. The running time depends on your internet speed and the length of your video. I will fast forward some steps, like downloading the model. At the cell, test with the user uploaded video and exemplar. Choose the video you want to colorize and wait for it to be split into frames. Then, upload your colorized reference image. Next, run the colorization step. This speed depends on the GPU in your Colab session, so I will fast forward this part. After this step, the frames have been colorized. So I'll add a code section to combine the colorized images into a video. In this code, I'll adjust the FPS to match the original black and white video, and then we'll have the final result. I will download the final video and show you the result. The hardest part of video colorization is keeping colors consistent across frames. If you've seen colorized videos on YouTube with flickering colors on objects, it means their method has algorithm limitations. Usually, they use deoldify or deep exemplar-based video colorization. Deep exemplar-based video colorization can give results close to ColorMNet, but color spreading is not as good because it's from 2019 and is old compared to the improved ColorMNet released in 2023. You'll see in this video that color flicker is greatly reduced during motion, and the colorization results are close to what professional colorization companies achieve. The next step is to upscale, enhance, and increase the FPS. In fact, there are many specialized software and workflows that can do this, but we usually choose the fastest and best way. So here I don't use the real SGAN model for upscaling or flow frame for increasing FPS. I use Topaz video. But if your footage has many faces, I recommend using Real SGAN together with EFGAN for the best face restoration. This is the step where you can clearly see the difference after upscaling and increasing the FPS. I'll choose the popular Proteus model, set it to 60 frames per second with some basic settings, and render a 5-second sample. Watch the upscaled video on the right. You'll notice the sharpness, clarity, and motion are much better. The scene feels much more vivid. Next is color grading the video. I use DaVinci to make the colors clearer and give the video a more nostalgic look. I'll add 2 nodes, and each node will have 2 plugins, one node for halation and the other for Canon's LUT color filter. After exporting the video, I'll show you the difference in the new video. Pay attention to the video on the right. You can see the colors look completely different in the video. On the right, colors in contrast are much more vibrant. Many people like to customize these filters. If you feel the colors are too strong, lower the filter settings when you apply it. Finally, I add simulated audio to the video. There are 2 popular models, AudioX and MMaudio. Since my GPU can't run the workflows for MMaudio and AudioX, I use the server from Running Hub. For the first audio sample, I tried without entering a prompt. Sometimes it turns out well, but in this case, it didn't. So I added a prompt and got this result. In the end, I combined the audio with the video and finished the colorization process. I hope my sharing is helpful for you. If you have any questions, please leave a comment.